Today, I'm going to talk about electric charge and electricity. Normally, these chapters must be studied in the 11th grade. What is electric charge? What is electric field? What is electric force? What is electric current? All these are very important for chapter 5 and 6. But because of the pandemic last year, I think you couldn't study these chapters. So now I will start in the same order of the 11th grade book, explaining them. And now, first, what is electric charge? I will talk about this. What does charge mean? So how do we obtain the charge in the nature? Okay, a good example is balance. I'm going to talk first about an experiment. When two balance are kept close to each other, you are going to observe that they will stay at their natural position. There will be no tendency of repelling one balloon to another one or attracting one balloon to another one. But after you rub this balance with your hair, you can do this experiment at home as well on your own. Two balance, rub with your hair, just that woman does in here. So then suspend them from a fixed point, from a pinpoint. You are going to observe that after rubbing, these two balloons start to repel one another. So something has changed about the balloon while you are rubbing them with your hair. That thing is electrical property. Electrical property of the balloon changes while you are rubbing this balloon with your hair. Initially, the balloon is at neutral state. Neutral means not to tend to attract something, not to tend to repel something. It's neutral, not natural. Neutral means, in fact, natural. But after you rub this balloon with your hair, this balance electrical property changes. These balance are called, in this case, charge balance. They gain charges. Now I'm going to explain how they gain this charge in details, but the difference is this. Initially, these balance are neutral. They don't tend to repel or attract one another, but after rubbing with your hair, they are not neutral anymore. They are charged balance. So what happens while you are rubbing the balloon with your hair? If two balloons are rubbed across your hair, the balloons will repel each other. If they are repelling each other, which means they gain similar electrical property. When you rub one balloon with your hair, another balloon with your hair, and then they gain a electrical property which is similar, alike properties. That's why they repel each other. But you can also observe that when you make this balloon close to your hair, you are going to observe that this balloon will attract your hair. If it attracts your hair, so electrical property of the balloon and the hair must be not similar. Opposite property in this case. Unlike property, unlike electrical property. So first one is alike, second one is unlike. So the first scientist who realized this is Benjamin Franklin. And he classified these two opposite behavior of the electrical substances according to two groups of charges. He classified electric charges into two groups, conventionally. Conventional means just giving a name, conventional. We are going to talk about this word in the chapter 5. What does convention mean? By convention. On his own, without not depend on a rule, just conventionally giving a name. For example, my name is my father and mother gave this name conventionally. There is no rule. Your name is another name. So if it's Aisha, give your mother and father on their own. There is no rule for that. Convention means that. Benjamin Franklin classified charges into two groups conventionally. So he said that, okay, first group, let me say positive charge object. Second group, let me say negative charge object. He's the first scientist who classified the substance according to their electrical properties, positive and negative. And he said that, okay, if this balloon and hair attracts one another, their electrical properties must be unlike, opposite. which means one of them must be positive, the other one must be negative. Oh, okay, which one is positive? He's going to say, which one is negative? Again, conventionally, he decided this. He said that, okay, balloon gains negative charge. Okay, here gains positive charge. That's why unlike charges, they attract one another. Then a common rule in physics appears. What is that rule? Unlike charges attract one another, which means positive attracts negative or negative attracts positive. But what about two balloons? They are like charges. And Benjamin Franklin said that the charge on the balloon is negative. Okay, in this case, both balloons are negatively charged. So like charges, they are like charges, so they repel one another. So this is another common rule in physics. Like charges repel one another. Yani negative repels negative, positive repels positive. So this is how concept of electric charge appears in the world of physics after Benjamin Franklin by some experiments. Okay, now I will continue. Okay, where does this charge come from? What is the origin of electric charge? Now I am going to talk about this. Origin of the electric charges, ladies, are the atom. All electric charges coming from the atoms. So that's why now I will talk shortly about the structure of an atom. So an atom has two basic parts. One part is the nucleus of the atom, which is the center. Here is called nucleus. Second part is outside the nucleus, which is the region. Maybe 99% of an atom is the outside the nucleus. Maybe 1% of the volume is the nucleus. Nucleus is so small. However, nucleus is very important because inside the nucleus of an atom, there are two important particles exist. One of them is the proton. Protons are positively charged particles. They gain positive charges, protons. They are inside the nucleus of an atom right here. Second particle, which is inside the nucleus of an atom, is the neutrons. Neutrons are uncharged particles. They are uncharged. That's why they are not our concern for the perspective of the 12th grade. Neutrons, they are located at the center of an atom, which is called nucleus, and trapped in the nucleus. And these protons and electrons cannot move. They cannot leave the nucleus of an atom. They are trapped. But around the nucleus, there are some orbits. On these orbits, electrons are revolving just like planets are revolving around the sun. This is in chapter 8, we will talk about the structure of atom as well, once again. And this model of the atom is known as planetary model, just similar to the solar system. At the center of the solar system, we have the sun. At the center of the atom, we have nucleus. Inside the nucleus, we have protons and neutrons. Protons are positively charged particles. Neutrons are uncharged particles. But around the nucleus of an atom, electrons are revolving in several orbits. So electrons are negatively charged particles. So as I said, there are two types of charges in the nature. One of the positive, the other one is negative. So positive is protons. Negative is electrons, but uncharged particles are neutrons. These are three basic particles inside an atom. But electrons are located outside the nucleus of an atom, and they can move around the nucleus. They are moving around the nucleus just like the planets revolving around the sun. That's why they can easily transfer from one atom to another. Electrons, I will talk about this in details in coming slides. Electrons are able to move from one atom to another, from one orbit, the outermost orbit of an atom to the next atom. But protons and neutrons, they are trapped inside the nucleus. It's impossible to take a proton from the nucleus without nuclear reactions. Maybe you heard about nuclear reactions. Normal chemical reactions cannot do that. Electrons are able to move from one atom to another one, but protons are trapped inside the nucleus of atom, so they cannot move from one atom to another atom. Just like materials, atoms can also be neutral or charged. Okay, natural state of every atom is neutral. Yani they are not charged. What does not charged mean? In fact, they carry charges. They have protons, they have electrons. Now, there is a model on the left of my screen. You see that this atom, this model consists of 1, 2, 3, 4 protons. And number of positive charges are 4 protons. And this is the nucleus of the atom. Inside the nucleus, there are 4 protons. But around the nucleus of an atom, there are 4 electrons as well. 1, 2, 3, and 4. So number of negative charges are also 4. Number of positive charges are also 4. So which means number of positive and negative charges are equal. This atom in chemistry, or also in physics, is called neutral atom. Now, it doesn't tend to be positive or negative. It's just natural, just neutral state. So this atom is called neutral. Net charge of this atom is 0. Even if there are charges, yes, there are charges, positive charges are inside the nucleus, negative charges are around the nucleus. However, their numbers are equal, which means one positive is cancelled by one negative. Another positive is cancelled by another negative. This positive is cancelled by that negative. Another positive is cancelled by another negative. If number of protons and electrons are equal, they cancel the effect of one another. That's why we say that net charge in this atom is 0. And no net charge on the atom. This atom is called neutral atom. But some atoms can have more protons than the electrons, just like this example. Here I have 1, 2, 3, 4 protons. 4 protons, but number of electrons 1, 2, 3, 4, 5, and 6. So number of electrons are greater than number of protons, which means there are 2 additional protons. Yani, if I make cancellation, I can say that 1 proton is cancelled by 1 electron, another proton is cancelled by another electron, third proton is cancelled by third electron, fourth proton is cancelled by fourth electron, but other 2 electron remains additional. So there are 2 excess electrons in here. This excess electron gives this atom a negative charge. Yani net negative charge of this atom is 2 electrons, negative 2. In chemistry, we are going to represent them by negative 2. And that's why we said that there is a net negative charge in this atom. There is a net negative charge in this atom. This atom is charged atom, not neutral. Negatively charged atom. Another name is ion. Charged atoms in chemistry is called ions. So this is a negative ion. We can charge an atom positively as well, but this time it's going to be different. Now look at the one on the right. Here I have 4 protons inside the nucleus of an atom, and I have 2 electrons revolving around the nucleus of the atom. So now, this positive is cancelled by this negative. This positive is cancelled by this negative. Okay, but now I have 2 additional positive. This time, 2 protons are giving net charge to this atom. Yeah, net charge of this atom is 2 protons, generally representing chemistry then positive 2. So there is a positive net charge in this atom right now. And this atom is not neutral. It's also a charged atom. But positively charged atom, this positively charged atom is known as positive ion. Then we can say that if an atom has greater number of protons than number of electrons, this is a positive ion. It's a positively charged atom, which is called positive ion. Now, we classified the atoms according to their electrical properties. One of them is neutral atoms, which means they have equal number of protons and electrons. That's why electron and proton cancel the effect of one another. So net electric charge for atom becomes 0, which is called neutral atom, no net charge. If number of electrons are greater than number of protons, which means there are additional electrons, excess electrons, so this atom is known as negatively charged atom or negative ion. If number of protons are greater than number of electrons, or vice versa, number of electrons are less than number of protons, In this case, there are additional excess protons. So protons are positively charged particles. That's why this atom is called positively charged atom or positive ion. So we can charge atoms positively, negatively, but we know that substances are made up of billions of atoms. If we are able to charge atoms positively and negatively, we are able to charge materials also positively and negatively. What happens while you are rubbing a balloon with your hair is this thing, what is happening. And atoms are charged positively and negatively, and as a result, materials are charged positively and negatively. Now we are going to make a closer look to rubbing a balloon with your hair. What happens in here? Now we will look in the perspective of the atoms. Of course, a balloon in your hair contains a very large number of neutral atoms. Remember, natural state of an atom is to be neutral. An equal number of protons, and not electrons. Your hair has equal number of protons and electrons. Your pen has equal number of protons and electrons. Or a balloon has equal number of protons and electrons. Atoms of the balloon have equal number of electrons and protons. And all they are neutral at the beginning. But while you are rubbing, something is happening. While you are rubbing a balloon against your hair, this time, some electrons are transferred from your hair to the balloon. Balloon gains electrons from your hair. Electrons in your hair leaves your hair and goes to the balloon. The atoms of your hair loses some electrons. If electrons are lost, what does it mean? Positive number becomes greater. The number of protons becomes greater than the number of electrons. So more protons appears on your hair than number of electrons. If there are more protons, so what does it mean? It's a positively charged object. Then your hair becomes positively charged. Hair becomes positively charged. Where does this lost electron go? From hair to the balloon. And these electrons lost by your hair is gained by the balloon. Atoms of the balloon gains those electrons. In this case, number of electrons on the atoms of the balloon becomes greater than number of protons. If number of electrons are greater than number of protons, so what kind of charge is it? Net charge becomes, of course, negative. That's why now more electrons appear on the balloon than the protons. That's why balloon becomes negatively charged. So this is what's happening. You are changing location of the charges. You are transferring charge from your hair to the balloon. Balloon becomes negatively charged because electrons are negative charged particles. Because electrons are leaving your hair, number of protons becomes greater than number of electrons. That's why your hair becomes positively charged. They're opposite charges, unlike charges. Now look at here. Balloon is negatively charged. Your hair becomes positively charged. Okay? If it is positive and negative, unlike charges, what happens to them if they are unlike charges? They will attract each other. That's why balloon starts attracting your hair, or your hair start attracting the balloon, because they are unlike charges. Okay, is it clear until here? Any questions?
Teacher, what was the reason that balloon became negative?
Because electrons are leaving your hair and going to the surface of the balloon. So that's why balloon gains extra electrons from your hair. Extra electron means negatively charged object, or extra electron leads a negatively charged balloon. But because electrons are leaving your hair, number of electrons decreases, which means number of protons in your hair becomes greater. That's why your hair becomes this time positively charged. You got it?
Yes, thank you.
Any questions?
Teacher?
Yeah.
Is it like the electrons always are transferred from our hair to the balloon?
Exactly. When you rub, not only balloon, if you rub your hair with your comb, you are going to observe the same effect. Electrons will be transferred from your hair to the comb. Comb will be negatively charged. Your hair will be positively charged. Yeah, you are going to be positive if you rub something with your hair. When you rub your hair, a balloon with your hair, some electrons from the atoms of your hair are transferred to the atoms of the balloon. And, of course, atoms of your hair loses some electrons. So atoms of your hair loses some electrons. Of course, atoms of the balloon gain those electrons. And in your hair, there will be more protons than the electrons. And more proton means hair becomes positively charged. But on the balloon, more electrons than the protons. That's why balloon becomes negatively charged. Okay, positive charge on your hair is equal in magnitude to the negative charge on the balloon. Why? Because how many electrons are left from your hair resides on the balloon. So one of them becomes positive charge, which is your hair, positive Q represented like this. Other one becomes negative Q. One of them is positive 10, the other one is negative 10. One of them is positive 5, the other one is negative 5. One of them is positive billion, the other one is negative billion, and so on. This is in physics is called as conservation of electric charge. Yani you don't create a charge or you don't destroy a charge. Only you transfer the charge from one substance to the next one. So this is called as conservation of electric charges. Yani you don't create a charge, you don't destroy a charge. What you do is to transfer the charge particles from one substance to another substance. Whatever total charge in the beginning is, and at the end of this transfer, sum of the charge will be the same. This rule is known as conservation of electric charge. In fact, you learned what conservation means when we are talking about conservation of angular momentum in Chapter 1, Chapter 2, Section 3, and also conservation of mechanical energy. This is another conservation law, conservation of electric charge. Okay, a simple example to you. When a rubber rod is rubbed with a wool, the rod becomes positively charged. What can you conclude about the magnitude of the wool's charge after rubbing process? Pardon, rod becomes, sorry, I did opposite, sorry. Yes, rod becomes negatively charged. Question saying you that if rod becomes negatively charged, wool should be positively
positive.
Yes, opposite. They are only thing we know that their charges are opposite in sign. If one of them is positive, the other one is negative. And some electrons from atoms of air are transferred to the atoms of balloon. We learned that if your hair loses one electron, balloon gains one electron. If your hair loses 2 electrons, balloon gains 2 electrons. If your hair loses 3 electrons, balloon gains 3 electrons. So one proton in this case, if your hair loses 1 electron, 1 proton more than number of electrons in your hair. But in the balloon, 1 electron is more than number of protons in the balloon. So charge of 1 proton is 1.6 times 10 to the power of negative 19 coulomb. This number is important. Charge of a proton. It is positive. Positive 1.6 times 10 to the power of negative 19 coulomb. Charge of an electron is negative 1.6 times 10 to the power of negative 19 coulomb. So one of them is positive, the other one is negative, but their numbers are equal. That's why a proton, an electron, has equal magnitude of the charge, which is 1.6 times 10 to the power of negative 19 coulomb. This number is constant. This is one of the basic, very important constant in the nature, which is about electricity. Charge of a proton, charge of an electron equal in magnitude, 1.6 times 10 to the power negative 19 coulomb. 1.6 times 10 to the negative 19 coulomb. And one of them is positive, which is, of course, proton. One of them is negative, which is, of course, electron. This number is called fundamental unit of charge, which means it is the smallest charge in the nature which exists. No small charge exists in the universe than this number. It is the smallest charge an object can have. So 1.6 times 10 to the power negative 19 coulomb. Coulomb is the SI unit of electric charge. Maybe first time you heard this. Coulomb, just like unit of mass is kilogram, unit of electric charge is coulomb. Unit of temperature is Kelvin, unit of electric charge is coulomb. Coulomb is unit of electric charge. And elementary charge or fundamental unit of the charge, which is the smallest charge in the universe, which is the charge of a proton, which is charge of an electron, is 1.6 times 10 to the power of negative 19. Clone, we are going to talk about this in chapter 8 as well. So charge of a proton is represented by positive E because it is positively charged. Charge of a negative electron is represented by negative E because it's negatively charged. So sometimes you are going to see this in some books. Instead of writing charge of an electron as 1.6 times 10 to the negative 19, they will write negative E. For proton, they will write positive E. You will understand that E is 1.6 times 10 to the power of negative 19 coulomb. What if not one electron is transferred from your hair to the balloon? If 2 electrons lost by your hair, these 2 electrons will be gained by the balloon. 2 protons more than the number of electrons in your hair, 2 electrons are more than the number of protons in the balloon. In this case, charge of hair becomes 2 times of 1.6 times 10 to the power negative 19. In this case, charge on the balloon becomes 2 times of negative 1.6 times 10 to the power negative 19 because number of protons on your hair is additional proton is 2. Number of excess electron on your balloon is 2. That's why you should multiply this elementary charge, smallest charge, and 1.6 times 10 to the power negative 19 by 2. This is known as in physics that electric charge is quantized. What does quantized mean? Charge on a substance occurs at integer multiples of E. Yani you can transfer 1 electron, 2 electrons, 3 electrons, 4 electrons, but you cannot transfer 1.5 electron. You cannot divide an electron into 2. You cannot transfer a charge 1.1 electron. Integer, it must be integer. Quantized. Chapters 8, we are going to meet this word again. What does quantized mean? Integer number. 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, not 1.1 electron, not 1.2 electron, not 1.1. It is integer number. Integer number, if a quantity is changing by integer numbers, it's called quantized. Electric charge is quantized because electric charge occurs integer multiple of E. Yani 1E, plus minus 1E, plus minus 2E, plus minus 3E, plus minus 4E, plus minus 5E, 6E, and so on. Then, to get the magnitude of the charge on an object, you should multiply number of charge by fundamental unit of charge. Number of charge is M, fundamental unit is E. When you multiply these two, you will get the charge of an atom or charge of a substance. Okay, do you got what quantized means? This is very important. Chapter 8, we will meet this term once again. Quantized.
It means integer number?
Yes. Yani, electrons can be transferred from one substance to another one by integers. 1 electron, 2 electrons, 3 electrons, 4 electrons, but not 1.1, not 1.2, not 1.3, because you cannot divide it. You cannot divide electron. I am going to transfer half of the electron from this substance, half will stay. No. You will transfer 1 or you are not going to transfer any. This is what is called quantized. 1, 2, 3, 4, 5, 6, and so on. All right. And
teacher.
Yeah.
The last sentence. It's written, can you go back? Yeah. Number of charge times fundamental unit of charge. That number of charge means like the 2 and 3 in front of the E?
Yes, 2, 3, 4, 5, 6. How many charge you transferred from one substance to another? That is the number of charge.